In this lecture, we will discuss about the random variable. So how to generate the random variable, what is the role of random variable, how many random variables are there, so types of random variable basically. So we start with the random variable. So for defining the random variable, we remember we have a sample space. Okay, so we have a sample space denoted as S, and there are element of sample space. Now we define as a random variable, or we can say that random function, random function is to associated associated each outcome with each outcome in the sample space with real number, with real number. So this is the sample space S. So in sample space S, we write down here as that means associated with each outcome in the sample space as with a real number. So basically random variable is denoted by a real number. This can be in the form of the real number. Now how to understand the random variables? So while tossing of two fair coins, tossing of two fair coins. So when two coins are tossed, so first we make the sample space. The possible outcomes are both are head, one tail and one head, and both are tail. So there are four possible outcomes. Number of element in sample space is equal to 4. Now, how to write the random variable? So we for writing the random variable, so we basically then give the nomenclature. So that means name of the function. Random variable is a function, name of the function, or we can write down the random variable. So this we can denote it by capital X. So the random variable we denote it as X. So first we define X. So what is X basically? That means we are defining for define function X. So contain that X contain the number of heads, contain the number of heads, contain the number of heads, or second we can make the number of tails. So first we consider for number of heads. So this number of head basically we denoted by the real numbers. So random variable, so you write down this thing, the random variable will always have a real number, have a real number. So two things we have discussed. One is sample space, second is event as an output. So The random variable we represent by a number. So that number first consider for number of heads. So that means this is basically a event. Event we denoted having one head, two head, zero head. So the number, when we represent this into the form of a number, so that number is said to be a random variable. So now when we make a sample space S, so we make a table. Sample space contain four elements: head, head, tail, head, and both are tail. Now, on the basis of these four elements, we write down the random variable. So this is our random variable. Random variable we are going to write on the basis of occurrence of head. So number of head, first is occurrence of heads and then number of heads. So here we have two heads, here we have one head, here we have one head, and we have zero head. That means both are tail. So the random variable we represent in the form of set. So this can be written as zero head, one head, and two head. Repetition is not allowed in set theory. So this X is said to be a random variable. So this is a random variable for given example. Similarly, when we talk about the number of tails, the same number we get for the number of tails. So for number of tails, we get the zero one tail, and two tail. So the random variables remain same for number of tails. So this is also same. Random. Now we take another example. Write the random variables for tossing of single coin, tossing of single coin, and the random variable X we represent it as getting a head, getting a head. So first we make the sample space as having two element head and tail. Now when we write down the sample space as H and T and random variable X, so getting a head is 1, not getting a head is 0. So the random variable X we denoted as 0 and 1. Getting a head or not getting a head. So 0 or 1 be the random variable for this question example. Next is three coins are tossed. Three coins are tossed simultaneously. Write the sample space and a random variable for getting heads. So sample space has contain 8 elements. So that means all three are head. Two head, one tail. So that means head, tail, head. Uh, tail, head, head. Now tail, head, tail, head, uh, head, tail, and all are tail. So 1, 2, 3, 4, 5, 6, 7. So sample space has having 8 elements. So for 8 elements, we write down the first as sample space as. Now on the basis of X, write down the random variable. So all three are head, head, head or tail, head, tail, head, tail, head, head, tail, head, tail, 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 head, head, tail, 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 and tail. So getting a head. So that means we are getting three heads. Random variable x having number three, two heads. Here two heads, two heads, one head, one head, one head, and zero head. So these are the random variables. When you write down the random variables, so that random variable will be in the form of 0, 1, 2, 3. So these are the four random variable for the particular example. So random variable basically a real numbers. Real numbers depend upon the occurrence of a head, or similarly we can do for the tail. So tail may we also write down the random variables. Now we discuss about the types. So types of random variable. So there are two types of random variable. One is discrete random variable, second is continuous random variable. So types of random variable, one is discrete random variable. Discrete random variable. Second is continuous random variable. Continuous random variable. Discrete random variable we represented by number 1, 2, 3, 4. So such type of numbers that are called the discrete random variable. That means number of student in a class be the part of the discrete random. So 30, 40, 50, 25. And continuous random variable. So continuous random variable example, best example is the height of a person. Height of a person. So this is the example of, suppose we can take the fraction or can be represented in the form of the interval 1.71, 1.72, 1.73. So such type of examples are the continuous random variable. Now we move to the further, that is the probability distribution of random variables. So probability distribution for random variable. So this is the basic part. So for describing the probability distribution, so we write down as a description giving the value of a random variable, giving the value of a random variable with the corresponding probabilities. With corresponding probabilities is called probability distribution of random variable. Probability distribution of random variable. Probability distribution of random variable. So now we explain this as, let the random variable, we takes the random variable we denoted as capital X. So random variable X as X1, X2, X3, and so on, Xn. With respect to the probability, with respect to the probability we denoted as P as P1, P2, P3, and Pn. So we have a random variable X and probability. So then the probability distribution, then the probability distribution, okay, distribution of the probability of a random variable X is given by, so we can represent this by using the table. So X and the probability of random variable X, that is noted as P of X. So we taken as X1, X2, X3, and so on, Xn. And corresponding probabilities we can denote as P1, P2, P3, and so on, Pn. So this is the distribution of the probabilities of random variable. Now we remember one thing. So then the sum of the probabilities, that means total probability. The total probability, the total probability should be 1. So this when we written as I summation of I equal to 1 to n into pi is equal to 1. So the sum of these probabilities is equal to 1, and each probability, also remember, each probability pi should be greater than equal to 0. So now after understanding the probability distribution of random variable, so we consider basically two things. One is random variable, second is corresponding probability of each random variable. So we take one example related to that. So earlier we have taken the example for generating the random variable. Now we write down the distribution for that. So for writing the distribution, so that we take the question in this way. So find the probability distribution. Find the probability distribution. Find the probability distribution of of number of heads in two tosses of a coin. In tosses of two coins. Basically, tosses of two coins. So when two coins are tossed, so the sample space we can write down directly. Both are head, one tail and one head, and both are tail. So the possible outcomes having only four elements. So that means the NS having four elements. So the random variable, now we write down the random variable. We denoted this random variable as X. So X we represented a number of heads. So we represented number of heads in tosses, two tosses. So when we toss the coin, so how many heads are possible? So that means two heads are possible. So two heads, one head is possible. One head, and no head is possible. That means both are tail. So the possible outcome, that means random variable, 0 head, 1 head, or 2 head. So we have three real values. So the possible values of x is 0, 1, or 2. So the possible values of x is 0, 1, and 2. Now, how we want to calculate the probability? So for calculating the probability, so for calculating the probability, we move to the first one. That means probability of random variable x equal to 0. So probability of random variable x equal to 0. It means that you are going to calculate the probability of getting zero head. Getting zero head. So zero head means no head. So both are tail. So how many element in this? So that means only tail, single element in this. So single element in this of any upon ns. So event occurrence of E is no head. So that means this will be the 1 by 4. Second probability of x equal to 1 means probability P of getting one head. Getting one head. So how many element of getting one head? So there are two elements. One is head tail or second is tail head. So how many element? Two element is there. The 2 upon 4. Possible outcomes are 4. So ns equal to 4. So any upon event occurrence of event E, this. So 2 upon 4. Now probability of x equal to 2. So that means this can be so getting two heads. Getting two head. So getting two head means both are head. So both are head only single element. So this is getting both head only single element. So this having the probability is 1 by 4. So now we put these thing into the table for required distribution. So we write down as the required distribution. So random variable x contain three elements 0, 1, or 2, and write down the corresponding probability. Probability not getting a head is 1 by 4, getting a head is 1 by 2, and getting two head is 1 by 2. So this is our required distribution, and we do the sum. We sum of all the probabilities. So sum of all the probabilities is equal to 1. 1 by 2 plus 1 by 4, 3 by 4 plus 1 by 4, 4 by 4 is 1. Hope you understand the random variable concept.